Okay, here are the materials for the limiting reactant lab. There's a piece of aluminum foil that we're going to react with some copper chloride. First thing we got to do is find the mass of the aluminum foil. So here I'll put that on the balance. It's not important exactly how much it weighs. In other words, we don't have to pre-weigh it. But when I put it on the balance, it'll tell you the mass. So it's like 0.61 grams of aluminum foil. And then we want to measure out about 50 milliliters of copper chloride. So 50 milliliters of 8/10 molar copper chloride will be about 0.04 moles of copper 2 chloride. We need the exact mass, so here I'll measure the volume. So there's actually 49.7 milliliters of copper 2 chloride. Now the reaction goes that I'll put the copper 2 chloride into a beaker. You can note its initial color. Here I'll hold it up against the white background. So that gets reacted with aluminum, and I don't want to ball it up, but I'm going to put the aluminum into the reaction. And you'll notice that a reaction will occur pretty much immediately. The solution will bubble and fizz and whatnot, and there's some heat generated. And it turns out that while this reaction is taking place, you can clearly see some copper forming down in the bottom. But as the reaction continues, you can see a little bit of water vapor coming off the top from the heat that's generated. And I gotta get this down in here until the reaction finishes. A sign that the reaction is concluded is that the bubbling stops and any kind of temperature change stops happening, color changes stop occurring. As the reaction takes place, the copper will coat the aluminum. So in order to continue the reaction rate fast, if I keep stirring it around and bouncing it around, the copper will fall off of the pieces of aluminum. And we'll just let this continue on here just for a little bit. Now, what we want to do is collect the copper that's left in the solution. So in order to separate the copper, which is a solid metal, from the solution, we're going to filter it using some filter paper. The filter paper itself fits inside of a funnel. So this is the funnel here, and the filter paper is actually sitting underneath the reaction. So it turns out that the filter paper fits inside the funnel, and how you accomplish that is you fold the paper in half once, and when I fold the paper in half, it makes like a shape like this. When I fold it in half one more time, and it'll make a nice cone shape. And then whenever you open it up, there's one piece of paper on one side and 3 pieces of paper on the other side. This is the filtering part. So the smart thing here is to tear off a bunch of the excess paper. So I tear off that excess paper, and now I still have a nice conical piece of paper, and that fits neatly inside the funnel like that. But I need to know the mass of the piece of paper, and I'm also going to put some initials on it so that I know that it belongs to me. I'm going to write RS for remote student. So this is for all the remote students. And I didn't really want to get that wet there. So that could introduce a little bit of error, but you could redo it with not the little piece of water on it. So 0.87 grams is how much mass the piece of paper has, 0.86 gram. Probably use 0.86 gram because that would account for the little dot of paper. It's important to tear the paper off and to write our initials on there first, because the carbon and clay from the pencil could increase the mass of the paper just slightly. Anyway, so I'll fashion this back into a cone and place it in the filter funnel. It sits inside the filter funnel just nice, and then the filter funnel can sit inside the Erlenmeyer flask. And then it looks as if the reaction is complete, but I'm kind of rushing this just a little bit. When the reaction is complete, then you can pour the contents of the beaker into the filter flask, and now there's a little bit of product left over from some reaction down on the bottom. And what's left inside the beaker is just copper. but I want to get all that copper into the filter flask. So to do that, you can use a wash bottle, and the wash bottle can then rinse the copper down into the filter funnel like this. Try to make sure to get all the copper down in there. Don't want to lose any of the product. So that's pretty good. Now, it'll take a little bit of time for the water to finish running down through the filter paper. Here you can see there's still solution inside the funnel. So anyway, then all you got to do is just allow the water to continue to run down through, and once the water's all run down through, you'll end up with solid copper. That's the like reddish colored stuff that's in the paper. And then you gotta let the paper dry, so you can't weigh it again until tomorrow. But tomorrow I'll post another video of the weighing of the final product, and then if you subtract the mass of the paper from the mass of the paper with the copper, it'll tell you the mass of the copper that remains.